We've been talking about kinetic and potential energy. They both have joules. So joules is joules no matter what. So that means somehow potential energy and kinetic energy are equivalent. And that leads us to the conservation of energy. Energy is conserved. So that means what you have in potential energy, it can be no greater than what you have in kinetic energy as an object's moving up and down a hill. An example of that is a roller coaster. If you notice the graph, the green line is the potential energy and the orange line or red line is the kinetic energy. As you move up the hill, potential energy increases, the green line gets higher. The orange or red line stays the same. Now you're dropping down the hill. Potential energy is going down, kinetic energy is increasing until you make the curve and follow it on around. Throughout this entire time, if you notice, kinetic energy gets no greater than the maximum potential energy. So, by the motion of the roller coaster, you have kinetic energy and potential energy. You are a balancing act between the two. So they have to be equal, and that is called conservation of energy. So, if we have our roller coaster at the top of a 40-meter hill, and we have our cart for our roller coaster is 12 kilograms, what is that velocity going to be at the bottom of the hill? How fast will that cart be moving? This is where it comes into play. Conservation of energy says potential energy is equal to kinetic energy. So mgh equals kinetic energy is 1/2 mass velocity squared. So we put in our numbers. We know our mass is 12. We know gravity is 10. We know height is 40. And that has to equal 1/2 of 12 velocity squared. So we have 12 times 10 is 120 times 40 equals 6v squared. So this is 480,000, or 4,800 equals 6v squared. So velocity squared is equal to the 4,800 divided by 6, which is 800. So velocity is the square root of 800, which is 28.3 meters per second. So the cart at the bottom of the hill is traveling at 28.3 meters per second. So we know potential energy equals kinetic energy. So that means mass times gravity times height is equal to 1/2 mass times velocity squared. So let's look at a couple more examples. For example, what if we have a cart coming down off the hill, and we know at the bottom of the hill it has a kinetic energy of 1,500 joules. And we know the mass of the cart. Let's say the mass is 2 kilograms. Well, how high is this hill? That's our question. We know potential energy is equal to kinetic energy according to conservation of energy. So we know mass times gravity times height is equal to 1/2 mass times velocity squared. So that's 2 times 10 times height, h, 1/2. Well, we don't even have to do the 1/2. We know it's 1,500 joules. So we know 20 h equals 1,500. So that means height has to equal 1,500 divided by 20, which is 75 meters. So our hill is 75 meters tall. Let's look at another example. Back to our roller coaster. We know it started out with a potential energy of 3,000 joules. So at the bottom of the hill, how fast is it going? We know mass is 2 kilograms. And let's say our hill is 30 meters tall. So we know potential energy equals kinetic energy. So mgh equals 1/2 mv squared. Well, we know mgh is 3,000 equals 1/2 of 2 v squared. Half of 2 is 1, so 3,000 equals half of 2, 1, v squared. So v is equal to the square root of 3,000, which is equal to 54.8 meters per second squared. So that is our velocity at the bottom of the hill. So, will you really have a potential energy of 3,000 joules for a 30-meter hill? Is that correct or not? Let's look. 30-meter hill, we know the mass of our car was 2 kilograms. What should have been the potential energy on that hill? It should have been what? We got 2 times 10 times 30. So that's 20 times 30, which is 600 joules. We're off by 2,400 joules. How can we be off that way? Think about your roller coaster rides. You have a great big hill, then it goes down, and then you have another hill. Sometimes you might have a loop. So if you start off with a lot of potential energy here, and you go down and you don't go up all the way, you have some energy here that gets transferred into potential energy here, and it adds to it, so it makes it greater. That's how come you can have a difference like we had. So when you are doing these problems, the easiest thing to do is always remember your conservation of energy, where potential energy equals kinetic energy, mass times gravity times height equals 1/2 mass velocity squared.